Good morning, everyone, and thanks very much for attending. Hopefully today will be an exciting presentation which will make us all think a bit. Just tips on COVID: always wear a mask when out in public, wash your hands with soap or alcohol-based hand sanitizer, avoid touching your face, eyes, nose and mouth with unwashed hands, avoid close contact with people who are sick, cover your cough or sneeze with a flexed elbow or a tissue, then throw the tissue in the bin. Clean and disinfect frequently used surfaces and objects. Hopefully we all staying safe. Tech Talks for November, we're doing hydraulics in soil and vent, part 2. We have a whole series of these to go through. So hopefully you'll find some. Welcome to Tech Talks. Today we're having our presentation at the Geberit Hydraulic Tower. And if you've ever wondered what happens inside a sewage pipe when you flush the toilet or empty the bath or the basin, this is the place to see exactly what happens. The hydraulic tower is located in Limbro Park at Geberit's head office. On the hydraulic tower, we are able to look at various scenarios and to see how the hydraulics inside the drain pipes work. Using two colored waters, red and blue, we're able to see exactly how the air and the water flow and what is the correct and incorrect installation practices. Over the years, Geberit have been looking at the various problems that plumbers face in the installation of drainage, and they've looked at the various scenarios and simulated them to see how we could overcome those problems. And the advantage of the hydraulic tower is that we can better understand what it is that we're doing and how it should actually work. Just about every scenario is covered in the various options hydraulic tower. And of course, if there are any new things that come up, is that they are quite easy to simulate and to see what happens in that particular circumstance. Today, we'll just be looking at 2 areas. We're not going to look at the whole hydraulic tower. That would take us hours to do. And over the next few tech talks is that we'll be concentrating on the hydraulics inside drainage systems and trying to better understand what we should and shouldn't be doing. So as per our last presentation, is that in all hydraulics is that it is really the mixture of the air and the water that is important, and making sure that we have the right full ratio to be able to drain the solids away and keep the line running without any blockages. So these have obviously, we've been through them before. They're just a refresher because this is what everything is based around. Ideally, we want a filling ratio of in excess of 50% to between 50 and 80. You'll see if it is less than that, we're going to get insufficient flow and the efficiencies drop and then the blockages occur.
Living spaces and commercial spaces are in short supply, and they are expensive. They have to be flexible and adaptable in terms of both use and design. Solutions that minimize the space required for facilities, like a hydraulically optimized drainage system, would be most welcome. The problem: conventional drainage systems take up valuable space with their large pipe diameters and ventilation pipes running in parallel. In addition, horizontal pipelines, offset, or in the collector pipe, for example, have to be installed with a slope. Geberit SuperTube solves these problems. This flow-optimized system, with its sophisticated fittings, can be relied upon for a continuous column of air in the discharge pipe. There is no need for an additional ventilation pipe. The diameter of the pipelines can be reduced to D110, and horizontal pipelines up to 6 meters long do not require a slope. This equates to a space saving of up to 20% in the vertical duct. The gain in room height equates to up to 40% less suspension distance being required. More space with no loss of performance. With Geberit SuperTube, the maximum discharge capacity is 12 liters per Geberit PE bottom turn bend and Geberit PE backflip bend. Geberit solvent sets outflowing water in rotation and guides it around the floor connection. Inflowing water can flow in without a hydraulic blockage being created. The air column in the stack is maintained. In the case of a change in direction, for an offset, for example, a bottom turn bend is built in. The annular flow becomes a layered flow without disrupting the column of air. This change significantly reduces impulse losses compared with conventional bends. As a result, there is no need for the pipes to be installed with slopes. At the end of the offset, the Geberit backflip bend sets the water in rotation again. The air column is maintained. This is how optimized hydraulics can create more living space. Geberit SuperTube offers yet another benefit: simpler planning of the system and even faster installation. And that's where Geberit comes in. Take advantage of Geberit's personal project service for planning, implementation, or directly at the building site. Geberit SuperTube, the space gaining system.
What was quite interesting in that last part of the video there is that you are able to connect a pan right at the nose zone in the base of the stack. Conventionally, you would have had all of these big back venting, or you would have had over here a small back vent, and you'd have to have come into this stack on its own. Whereas with the super tube, we can actually connect here. Of course, this means that not every plumber can just go and install this and hope that it works. You've got to make sure is that you get the correct design. So Geberit offer that facility and the software for consultants. They talk about space saving, and if you think about the additional headroom that you can gain in this area here in your parking lot, where you can run for 6 meters dead level and then have a fall. And when you start to get to halfway up, sort of 10 stories up, you start all of your secondary stacks. We are now at this point is that we're saving all of this headroom here, and we're saving the duct space. So effectively, you could fit another floor in. But even if you don't fit another floor in and you still keep your design to 14 floors instead of 15, or 90 instead of 92, is your cost of service, or your cost of facade, cost of structure, cost of everything that is part of it is all saving to the client. And it's important that when we're specifying things like this or suggesting them, is that the clients are made aware of the benefits to them, because the benefit is both to the plumber and to the client. As you can see, the saving on this material versus this is just huge. So really, when you are doing the presentation, it's not about the plumber trying to be cheaper. It's about making sure that the client understands his benefits. So we're going to have a look at a few of the things that we're always concerned about. We're worried about what happens in this area here when this joins the super tube. So watch out for that when the video starts. So that's the norm turd. Rainer's famous norm turds going down the super tube. And you can see there's no interference in this position here on this stack. And what is interesting is to look over here and to see how much air there is in the system, which allows you now to bring in another connection in this area. So we're looking at various angles of this. We really want to try and understand exactly what is happening. And the principles of the super tube are a vortex of air in the pipe and making sure we can change direction. And so at the top of the sow vent here, we've got a direction changer. And over here at the bottom bend, we've got this direction chamber, which gives us air in this section of the pipe over here. So we're running at 5 liters a second, which is a hell of a lot of water. And the velocity will be around about 13 meters. So you have a slight glitch in my system here. So what's important to look at what happens with a low flow. In other words, when you've only got one toilet flushing, and this is flushing on 6 liters of water. And you can see how it carries right through on the 6 meters and then drops down. If you recall in the last presentation where we did the 90 and the 110 pipe, where we were saying we needed to reduce the pipe to keep the ratio correct, you see how much better the super tube performs. So this is the third component of the super tube, which is the backflip bend. And this is very important. You can't just put a normal bend here. You have to use this bend. Otherwise, the column of air doesn't go back properly. And what happens is there's a vortex that forms here. So like when you are on a super tube, you'll rush down and then you'll pick up onto the outside of the tube and then come back down again. Quite interesting. Note the vortex of air in the middle. So these demonstrations at the moment are all on fairly low flows of water. All of them around this at the moment about 3 liters per second. And the previous one was sitting at 5 liters per second. I want to get up close and personal with this stuff to see what's happening. Okay, you can see we're sitting at 9.6 liters and we're going to take it up to 12 liters per second. And again, you'll notice is that how much air is at the base of the stack and in this first section of the pipe, which is why we are able to then do another connection into that area. So when you look at the velocities of the water coming down and the amount of water, it comes back to our fixing and making sure that we take care of all of the fixings, including the expansion and contraction. We have to make sure that we secure this system properly and that the expansion and contraction is taken care of, which is why it is so important to make sure that we get the correct design and that we follow that design, is that we don't just move on and do what we would sort of like to do. So I want to spend a bit of time on this, the next on Tech Talks. The super tube is obviously amazing, but what we all do so wrong so often is this side of it over here, where we tend to use a lot of saddles and a lot of connections where we don't keep to the rules of keeping the distance between the various points. So you'll see what happens in this area here. And we're going to be looking next week at saying, how do we make sure that when we're doing our stacks that they are designed properly and that they operate correctly? Is that we often hear is that we have problems in the apartment blocks and that we are getting a whole lot of smells coming in through the bathroom or from a unit that isn't used that often. And a lot of that is a cause of the bad hydraulics and the filling ratio. And so when we are designing a stack, it's the SANS regulations give us the guidelines as to what we should be doing. But in practice, it doesn't always work like that, is that we do tend to pick up a lot more problems. And typically, this formation of the junction is something that in the SANS we're saying is the 45, but actually we need the 90. But if this distance is wrong, we start to get the backflow there. And so if you understand the basic principles of what we're talking about here, and then you think about the super tube, and the super tube is definitely a far superior system that has so many benefits for the client and for the contractor is that you can't mix the two. When you start putting these fittings into the super tube, into the middle of the line, because you think you quickly just want to put in another branch fitting, when you start having those velocities and that amount of water coming down from between 150 or 40 floors, is if you've done a correction that is not in terms of the design, you can imagine the disaster that you're going to have with that. So super tube, just going back through the components, is that we have the three major components of it. It is the solvent, and it's not the old-fashioned solvent. So the old-fashioned solvent and the one that is mentioned in the SANS regulations shows that the solvent is just diverts the water, and it has a very small breather hole in the back of the system. Whereas the new solvent for the super tube has got this V formation. And if you look at it over here, there's quite a big V in this section, and that turns the water around. So don't think if you've got stock of 10 old solvents, you can use them in a super tube. You are going to pick up quite a few problems. The second part of it is the bottom bend. And again, it's got this big V. And in that, this actually changes the flow of the water around onto this section here and creates the air pocket at the bottom here. And this air flows up through the top. So pocket's not the right word. This column of air in this section. So that means that a meter down, we can actually, or 1.5 meters down, we can connect back into this same base of the stack. So the three components are the solvent junction. And the solvent junction then means is that we are able to connect 3 toilets on this one axis here. And below that, we can connect up our shower, basin, bath, and kitchen sink. And again, you've got 3 connections all the way around. So when you're looking at the costing and you think that if you were to do that with junctions, and you then compare the actual cost of what you can do with the solvent, is that you'll find is that the solvent installation is a lot cheaper. You'll still notice is that these dimensions are still correct, because you still can't mess with those things. They have to be to the dimensions. So when you're doing a stack, as I say again, often is that we see saddles being put onto the line and they're not at the correct distance, and that creates problems. When the water goes back into the horizontal and it starts to suck the trap out again when the line finally clears. So the benefits of the solvent system, obviously in a basement where your cars are being parked, if you can take from the base of your stack 6 meters, that means you're going across the driveway and 1 parking lot. You're able to do that first section of line dead flat, right up against the soffit. Well, you're going to be probably about 200 millimeters down, because you need to make sure that the bend can fit in properly. So that means for the first 6 meters, you're going to run 200 millimeters. You'll then, on the other, once you pass that 6 meter, you'll then put in a conventional 4. So there you then take up a bit of space in the basement. But if you think that you've actually saved between 17 and 20 millimeters per meter on the first 6 meters, and if you can then have another downturn bend, sorry, a flip bend, then, and you go down vertically again, you can keep that same principle working. So when you're coming down a stack in a building, the best is never ever to come down all 50 floors straight, is that you want to bring it down 10, 15 floors, then offset, carry on down again, and then offset again. And that way you are reducing your headroom there. So concrete costs, reinforcing, weight of concrete, construction time, everything comes back into comparing plumbing systems. You can't compare a plumbing system fitting for fitting. You've got to go back and say, well, what are the benefits to the client? And how will he benefit by using a product like SuperTube or Pluvia, which is the siphonic rainwater, where again is that they are both based on your pipes running flat. So you don't need that additional headroom. If you think about building costs per square meter, and your building cost, let's say, for argument's sake, they're 10,000 Rand a square meter. If you can save half a square meter per duct going up in a 50-story building, that's a lot of extra room that you can put into the apartments. And if you're doing that by 20 or 30 ducts, that is really significant on a project. It all comes back to, again, is that our labor, we believe that it is cheap, but it's actually not cheap, is that we tend to flood our jobs with people just to keep up with the builders program. If we can think about a little bit more, plan our jobs beforehand, reduce your labor by 30-40% on a site, it means you've got less problems that should happen, and you'll be able to control that work better. Again, the products like Pluvia and Supertube are significantly more technical to install, and the things like their fixings and fastenings are a lot more expensive than doing it with a bit of PVC. But the reality is 10 stories of effluent coming down a sewer pipe, whether it's PVC, HDPE, cast iron, whatever it is that should all be bracketed properly. And we should really make sure that when we are tendering jobs and we put in the pricing in, that we price properly for fixed points, for taking care of expansion, for making sure that our guide points let the pipe move. And that way is that we avoid any damage onto the fittings. And we often see on a PVC pipeline is that where they've put it in as a rigid installation, and over the years is that the saddles and junctions start to leak because of the movement in the pipe, because we haven't taken care of that. The next benefits for the client are that if you're using a product like the Sovent, is you're able to make your ducts a lot smaller. And that means that you can actually bring those points in together all in one area and be able to cast a lot of that into the concrete. So in South Africa, it's not the traditional way of putting drainage into concrete. We always like to have it sort of up in the wall or in the duct and going around. Looking at the hydraulics and how we size the piping and that, it's important that we have all the pipe sizes from 32 mil up to 160 for our conventional drainage. And that means is that we're using all of those sizes to make sure that the hydraulics are correct and that the pipes are self-cleansing. And when you're doing your structure or you're doing your drainage in the structure, is if you think about the saving at the end of it, is that you are working with the contractor at the time that he's putting in the slab. And that means is you put your stuff into the positions that you want it, and you won't have to go back and chase and break walls. So in another couple of series further on down in Tech Talks, we'll be looking at casting pipes into concrete, the do's and don'ts, the movement, the problems, the expansion joints we have to cross, and how we can also then cast in our water piping and make sure that they are properly protected and that we don't have to go back and do any additional work. Think about the carcass of a drainage system. Wherever your drainage goes, you need water. Hot and cold or just cold, you need the water. In the ducts, we're going to look at circulation in the future as to how we're balancing things and that, but that'll be probably mid next year sometime. So technology in plumbing is really moving on, and it's an exciting time. And people, it was always that, oh, my child's a bit dwarf, can he become a plumber? Which is actually nowadays in plumbing, it's not that your child can't be dwarf. He's actually got to be quite smart to do plumbing, and plumbing is complicated. So in closing, special thanks to Gebrit for making their facility available to us. And most importantly is for allowing us to pass on the know-how installed. That philosophy of installing the stuff correctly and understanding what's going on is just amazing how Gebrit are sharing that with us all. Again, we're getting near the end of the year, but any training that is required on the Gebrit products, it's all free. Give us a call, send us an email. We've had a couple of inquiries from our last presentation. And just obviously the end of the year is getting quite close, and we've got a lot of things to finish off. But we still will be having another 4 training sessions where people will be able to attend this year. If there's a site that is doing a gibbered installation and they have a need for their operators to be installed, please give us a call. We want to make sure it's done properly, and we want to make sure that the standards get uplifted.